Up until now, we were laser focused on changing the source IP address of the packet. This behavior falls into an umbrella which is commonly known as source NAT. But in this video, we will focus on Destination NAT. Now, as the name hints, this type of NAT changes the destination IP address of the IP packet as it traverses through the NAT device. Now, a quick pro tip here. If we are changing both the source and the destination IP address of the packet at once, that NAT is termed as Twice NAT because we are changing the IPs, quote unquote, twice, one for the source and one for the destination. Now, to kind of make sense of the Destination NAT, let's have a look at an example from our NAT beginner series where we alter the outside local address to achieve Destination NAT on the Cisco router. Outside local address is the local IP address from the private network which your local host sees as the IP address of the remote host. Now, if that isn't frying your mind right now, nothing will. But don't worry, we got this. Let's just break down the terms and reverse engineer it. Now, outside signifies it's a device sitting physically outside of your organization. So it's somewhere out there on the internet, right? Local means the perspective of the local clients of how they see that IP address. In our case, PCA and PCB will see that address as 111.1.1. Now, the confusion mainly arises here because we already have a term outside global address that basically shows the same thing, right? I mean, think about it. If everyone else on the internet sees a public IP as 111.1.1.1, aren't we gonna see the same thing as well? The answer to that is a resounding yes. And that is the reason if you look at Cisco's show IP NAT translations command, both outside local and outside global have the same IPs and port numbers. So why is the outside local even present if the viewpoint is the same? Well, it is there to facilitate a specific type of NAT known as Destination NAT. This is a type of NAT that has a very specific use and is very uncommon. Now, to really understand it, let us consider the following use case. The developers of Dr. Networks Corporation were accessing the website drnetworks.net by the IP of 111.1.1 up until now. Now, for some reasons, the IP of the server was temporarily changed to, let's say, 199.9.9.9. Now, instead of letting the internal users know the new IP address or changing the local DNS records for a short time, we can leverage the Destination NAT here, such that the users will still believe they're connecting to 111.1.1.1 with their perspective. But in reality, the destination IP will be changed from 111.1.1.1 to 199.9.9.9. So if we were to look at the show IP NAT translations command on the router now, the outside local address will be 111.1.1.1 and the outside global address will be 199.9.9.9. So you see how the local perspective of the local clients is now different. For the rest of the world, drnetworks.net will be accessible via the IP of 199.9.9.9 because that is the global perspective. So in the upcoming lab, we will be configuring and understanding Destination NAT and also see Twice NAT in action. So stay tuned. Now, truth be told, all the NAT types you have been seeing up until now were characterized as source NAT because source IP addresses of the IP packets were being changed. But in this case, it's different. Now we're going to look at changing the destination IP address as the packet traverses through the NAT router. Plus, we're going to be seeing source NAT plus Destination NAT in this lab. And this is vital for you to understand because the outside local address term that is most confusing to most of the people will be cleared in this lab. Now, just to give you a lab overview as we usually do, we have 3 PCs on the left side connected to a switch, which are on 192.168.10 series. And then we have our NAT router, which will be performing the NAT functionalities for this site. And we have our internet or ISP, and that is again a router. And it has two connections going towards a telnet server, which is on 111.1.1.1, and the other one is on 222.1.1.1. So basically we have two telnet servers. Let me just, all right, I think it's pretty fine here. So there we have menus, first of all, on these telnet servers. Just like in lecture number 1, you saw that we had telnet servers and we had menus on those telnet servers, because it makes things much more simpler. And just a heads up, as I always tell you, that this is a router. Oops, this is a router, okay? So I've just changed this icon, and this is also a router that I've changed the icon to a PC. Now I do that because I love the routers, so I can emulate them into acting just like a PC as I need in this lab. That's pretty easy for me to do. You could well use a virtual PC if you don't have the resources in your VMware or your VM player or your ESXi server, whatever you're running this on. If you don't have that, you don't need to do that, okay? So I just do it for my own sake and for your sake, so that I don't run into any bugs or something. So let's go over the lab information, what we have here. So everything except the NAT configuration on the NAT router has been configured. So IP addresses, routing, all have been configured. All the end devices are routers in disguise of a host. I just told you that. The NAT inside and outside interfaces have already been configured. Now, for the 3 labs, I was seeing that it took a lot of time for the inside and outside commands to digest for this router. So it took a lot of time. So what I've done is I've already configured them, so you don't have to wait for that to happen. And let's move on towards the steps. Alright, the first step in this lab is that connectivity must be established first from PC A, B, and C to telnet servers 1 and 2. So we can use anything. So first of all, let me just check the connectivity sitting on this NAT router over here and see if pings are working fine. So let's do a ping to 192.168.10.10, 20, and 30 and see if that's working. 192.168.10.10, so that's working. 20 and 30 all are working fine. And then we're going to do a ping to 111.1.1, and first of all, yeah, 1, and ping 222.1.1.1. so that is the IP address, right? All right, so we were given a free hand that we could do anything for the communication. Now obviously this is a private subnet, it cannot directly go towards the internet, so we will have to do NAT overload for them, just like we do in regular environments where we need internet access. So let's do that real quick. So we'll be configuring NAT overload for the source NAT first of all, because we want connectivity between the 111 and 222. So let's do that real quick. IP access extended, internet, we've just gone through all that. So permit permit IP 192.168.10.0 wildcard mask, and going towards any destination for that sake. Okay. IP NAT inside source. I'm going to say source list. I'm going to internet. Internet is the access list name. On the interface, I'm going to be overloading is 200.1.1.1. That's sorry, no, that's the IP address. Is gig 0/1, gig 0/1 overload keyword. Beautiful. So let us see if PCA can access 111.1.1.1, and sure enough it can. It will be able to access 222.1.1.1, and sure enough, let's do a telnet to 111.1.1.1, and admin Cisco is a username and password, and then we have that beautiful menu over here. So we could see that this is telnet number 1, the telnet server number 1, and you could check also your connection with 1, you can see that you got an IP address of 200.1.1.1, and that is its local address. Okay, so this is really important. Once we do destination NAT, you're going to see some really cool stuff happening here and there. So I don't think we need to check PCB and see they will be working. Just to check with the other channel server 222. So admin Cisco, that's also working great. So we got these guys run up, and they have basic connectivity towards both of the Talent Server 1 and Talent Server 2. So that is it with our step number 1. Okay, here comes the interesting step. Now we need to change the Telnet server 1's IP from 111.1.1.1, which already it has, to 999.9.9.9 and add the necessary routes. Now you could assume that all of these PC A, B, and C were connecting to 111.1.1.1. Maybe it was some sort of remote access, remote server. I don't know what it was, but for some reasons you could assume that we had this on our cloud, and they basically got into an issue, a fire or something. So they said, okay, we cannot give you that IP address. We're going to give you another public IP address that you can use. And that's going to be 999. So I'm going to change that real quick over here. That's going to be 999.9.9. Zero subnet. I'm going to change that. So it's going to be interesting. All right, so let's go towards our internet router. First of all, gig0/1 is the interface. So I'll be saying show IP interface brief, exclude and assign 0/1, right? So going into global configuration mode, interface gig 0/1, IP address 999.9. Actually, I just wait a second. If it's 9, no, I'll just change that to 1. Wait a second. I'll just change that to 1 real quick. So that there it is. So there is 1. So let's go towards that. So it's 999.9.9.2. 255.255.255.252. Beautiful. Now we're going to Telnet server 1, and I'm going to say that you have IP interface brief. What IP address you have? You have 111.1.1.1. I need you to change that IP address to 999.9.9.1. 255.255.255.252. Oh, sorry. This is a mistake I always make. 0.0. So IP address. All right, let's copy and paste that so that I won't have to type it again. So no shut, and now I have to change the default route as well, because that default route was for another subnet. This was it wasn't for this, so I'll just have to change that to no that, and let's do another default route with 999.9.9.2. So there it is. We got it. So what else do we need to do? I think it's pretty much it. Now it has reachability. That was basically the routes we need to do. Let's do first of all, let's do a ping to 200.1.1.1. And yeah, that's pretty much it. That's all we needed. Now here comes the most interesting step of this lab, and that is the users must not be communicated the changed IP, which is 999.9.1, and they should still connect to 111.1.1.1 with their perspective, and that is the local perspective. So what we can do right now is, if we wanted, I think we can still access double line. If we can ping that, there it is, you can ping it. But look at the NAT translation, show IP NAT translations. There it is. So we have our outside global address, that is 999.9.9.1, and then we had 999.9.9.1. That is the outside local. Now this one is the local perspective of the local clients. So PCA sees that address 999.9.9.1 as the same as it is. So let's say we don't want to share that IP address with our PCs over here. We want them to still connect to 111.1.1.1. So how is that done? So that is done by crafting a specific statement saying that, okay, my users will be connecting to 111.1.1.1, and I want them to be NATed destination-wise to this IP address. I'll see that in a minute how it's done. So let me just show you first that if I do a telnet first of all, if I do a ping to 111.1.1.1, it won't work because it's unreachable now. It's not on the internet. Okay, so what we could do, we could leverage the destination NAT. So now we already have some commands running on this router in terms of NAT. So we're doing at this moment source NAT. So source IP addresses are being changed. Now I know this is NAT overload, but the umbrella of this NAT is source NAT. Okay, so the source IP address is changing at the end of the day. So let's do destination NAT. So how do we do that? So that's pretty easy command. So IP NAT, we always use inside because we always change the inside parameters. Let's do outside now, because once you hit that key, you're now changing these parameters. You get it? So outside source, and that's going to be static. Now check that out. It said, what's the outside global IP address? So outside global address will be 999.9.9.1. And what will be the local IP address? In other words, what IP will the PC A, B, and C be communicating to with their perspective? And that will be 111.1.1.1. And boom, there it is. So now if we do a ping to 111.1.1.1, look at that. Isn't that amazing? Check that out. Telnet 111.1.1.1. And admin and Cisco. And beautiful, you're still connecting to Telnet server 1. Amazing, right? So now, as we have telneted it, let's do a show IP NAT translation here and see the magic. What's happening? Let's look at this TCP session. Now check this out. Beautiful, isn't it? First of all, you generate a source port number, and that is your IP address, that is PCA. And its IP address was changed from 192.168.10.10 to 200.1.1.1, which is the source NAT that we are talking about. But now, not only that, but the destination has also changed. Now, from the perspective of the local clients, they're connecting to 111.1.1.1 on port 23 because it's a telnet server. But in the back end, the destination NAT is happening, and that IP has been changed from 111 to 999. So let's go to this PC again and see the communications. Sorry. Now check that out. Nothing really amazing happening here actually. It's not that. Okay, one last thing I want to show you is a debug. I want to show you a debug. That's gonna be cool. I want to show you a debug here. Debug IP NAT. So I could actually do what was that command? Detailed, so you can see the port numbers as well. So let's do a telnet to 111.1.1 again. Check this out. Check this out. Oh man, this is a lot of statements. Wasn't expecting that. Well, let's go to the first one and see what happened. So our source IP address came at 192.168.10.10. That was changed to 200.1.1.1. And the destination was 111.1.1.1. Now this statement here is a source NAT statement. Now the next statement is source was 200.1.1.1, the destination was 111.1.1.1, and it changed to 99.9.9.1. Now this arrow basically means it has been netted. So amazing, right? So that is how you can leverage Destination NAT, and now you have a very good understanding of the outside local address, which has been a confusion for so many people out there. So I hope that has been resolved, and I hope this has been informative for you, and I'd like to thank you for viewing.